All right, hello everyone. Welcome back. I'm going to go through the last two examples here of our four different examples that I'm doing to try to elucidate or illuminate or whatever verb that you want the concepts in section 8.3. Okay. Let's start with this one. 2 sine squared of theta minus sine squared of theta equals 0. Okay, so these were also a section on the 8.3 homework where a lot of people struggled, okay, especially with this problem. So let's try to solve it. I'll rewrite it again as usual in my own handwriting. 2 sine squared of theta minus the sine of theta is equal to 0. All right. In these questions, what I'm asking you to do, or what the book is asking you to do, is to view these like a polynomial equation that you've worked with in the past, and then find the solutions. So, what that means is that it's probably easier for us to view this in terms of x and not sine squared. Okay? So if I reset, or I substitute in x for sine squared, what I get is 2x squared minus x is equal to 0. All right? Now there's an x common to both terms in the subtraction, okay, in the difference on the left, and so I can move or pull or distribute an x out, and I get x times 2x minus 1 is equal to 0. All right, and so at this point you should remember that I can find all the solutions here by sort of splitting this up. It means that either x must be 0 or 2x minus 1 must be 0. Okay. So the solutions in terms of x are x must be 0 or 2x minus 1 must be 0, which means x must be a half. Okay? Great. So those are the solutions in terms of x. Now we need to find the solutions in terms of theta. And so I want to find when the sine of theta is equal to 0 or when the sine of theta is equal to 1/2. Okay. So when is the sine of theta equal to 0? Right? So in the previous video, I drew out what sine looks like. Again, we'll do that here. A 0 happens at quadrantal angles, and so again, no special triangle is going to help us there. So again, sine looks like that very roughly, where this is 0, pi over 2, pi, 3 pi over 2, and 2 pi are the critical points. The max and min happen at 1 and -1. We don't care about the maxes and mins here. We care about 0. So where is sine of theta equal to 0? It happens 2 places. 3 places really, but we don't care about at 2 pi. It happens at 0 and pi. Okay, so the two solutions to this equation, sine of theta equal to 0, are 0 and pi. Okay, so that's the two there. And then I now need to think of when is sine of theta equal to 1/2. All right, so This is a special triangle, okay, very similar to the first question I went over in this one, except there I was looking at the 45, 45, 90 triangle. Here, sine of theta is equal to 1/2 corresponds to the special triangle for this angle theta, 1, 2, and the square root of 3. In this example, theta is equal to pi over 6, or 30 degrees. Okay? So, again, I need to think in terms of the x, y axis. Where I have the 4 quadrants. I want the points where sine of theta is equal to 1/2. Sine is positive in the first and the second quadrant. Okay, so if I draw my special triangle in the first quadrant, where 1 is opposite, 2 is hypotenuse, and then I don't care about the third side, the angle that forms that triangle is indeed pi over 6. So I got 0 and pi up above with the first equation. Now I got pi over 6, and then of course I need the other triangle that results in opposite of 1, hypotenuse of 2, and that special triangle has the interior angle of pi over 6, but of course that's a reference angle for the larger angle which I want to find. 180 degrees is pi, so what do I have to add pi over 6 to get 2 pi? That is 5 pi over 6, and so that gets that fourth answer. Okay, so again, when we had something more complicated up here, we used a dummy variable to change it, okay, to something that we knew more how to use. And so that's what we're going to, that's the common thing that we're always going to do. All right, so last one that we're going to look at, the tangent of theta is equal to 2 times the sine of theta. Okay, so this is sort of the last type of problem that you see, and this is another one that gave a lot of people some problems. And rightly so. It's probably the toughest out of the 4 that I've done. So we have that the tangent of theta is equal to 2 sine of theta. As always, I'll write it out in my worst handwriting. Here we have no real way of sort of moving forward with what we have right now. We need to use a fundamental identity to change this equality in some way. And so what I'm going to do, because I've got sine here and tangent, sine here, tangent here, and everything, like the 2 basic trig functions that we use are sine and cosine, and then everything is sort of, can be made out of sine and cosine, including tangent. So I'm going to change tangent to be sine over cosine. So the fundamental identity that I need, or that I want to use, is that the tangent of theta is equal to sine over cosine. Okay, so I'm going to rewrite tangent as sine over cosine. Equals 2 sine of theta. And then I'm going to rearrange. Here I'm going to multiply cosine by both sides. and get sine of theta is equal to 2 sine of theta cosine of theta. And then I'm going to divide this side by 2 sine theta okay, sine of theta divided by the sine of theta is equal to 1, and so what I'm left with at the end of this is that the cosine of theta is equal to 1/2. All right? So I've worked my way all the way down to the cosine of theta is equal to 1/2. Again, I need a special triangle, or I'm hoping for at least a special triangle with an adjacent side of 1 and a hypotenuse of 2. And of course there is that special triangle. And a triangle with an adjacent side of 1, opposite of root 3, and hypotenuse of 2. The angle that I'm looking for, which I'll call theta here, in this case is pi over 3, or 60 degrees. Okay, so I'm going to find where the cosine of theta is equal to 1/2 between 0 and 2 pi. Again, I want to draw my x, y axes. Okay, or rather it's probably theta y axis, but I'll always call it x for what we're used to. And then I've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Cosine is positive in the first quadrant and in the fourth quadrant. So I'm looking for special triangles in the first and in the fourth quadrant. So we'll start with the easy one in the first quadrant. Okay, that's the angle that we're looking for right here. So if we draw the special triangle of 1 square root of 3, 2, this angle is going to be pi over 3. And so that's the first solution there. Okay, and then the next one in the fourth quadrant here, where the adjacent side is again 1, the hypotenuse is the square root of 3, and then now the opposite side, which I don't care about, is negative square root of 3. That reference angle is again pi over 3, but I'm looking for the full angle to get here. What do I have to add pi over 3 to get all the way around to 2 pi? The answer is 5 pi over 3. So I know that the cosine of pi over 3 is equal to 1/2, okay, from the first part that I explained. And then I also know that the cosine of 5 pi over 3 is also equal to 1/2. So that gets me pi over 3 and 5 pi over 3, okay, which are maybe the sort of obvious ones. And then the extra ones that people might miss are 0 and pi. So for these, we're going to have to go back to the original equation. Because again, this is what we were originally working with. Okay? So you're going to have to think, this is what makes this problem tough. You're going to have to think about when, what values between 0 and 2 pi are going to make this 0. Right? And so usually these cases which give us trouble are going to be quadrantal angles, okay, because they don't sort of follow into the special triangle type of stuff that we're used to. And so this problem especially follows suit. When are tangent and tangent of theta and sine of theta equal to each other? Well, they both could be 0, okay, or I have to find where tangent is twice the value of sine. Okay, so you can go through, basically what you have to go through is what happens at 0, what happens at pi over 2, what happens at pi, and what happens at 3 pi over 2. Those are the 4 edge cases, some people like to call them, okay? What about at 0? Okay, so the first question is what about at 0? And so we see from the answers I put down that 0 is an answer. We know that sine of theta starts at 0. Okay, so the sine of 0 is 0. 2 times 0 is 0. And it turns out that tangent also starts at 0. So tangent, for reference, I'll write it small down here in the bottom left-hand corner. The tangent of theta as a plot looks like that, where it has vertical asymptotes at pi over 2 and negative pi over 2. But it is 0 at 0 as well. Okay, so sine of theta is 0 at 0, and tangent of theta is 0 at 0. So that will make them equal at 0. At pi over 2, tangent doesn't exist. Okay, at pi over 2, tangent does not exist. And so, not going to do us any good there. And so those can't be equal. What about at pi? What about at pi? Well, it turns out that again, at pi, tangent repeats itself every pi. And so there's going to be another tangent there. And it's 0 at pi. Okay, so tangent of theta is 0 at 0, pi, 2 pi, 3 pi, 4 pi, so on and so forth. Okay, so tangent of theta is 0 at pi. What about sine of theta? Well, if we draw sine of theta down here, it's 0 at 0. It goes up maximum at pi over 2. And then it comes down, and lo and behold, it hits 0 at pi, and back up. Negative at 3 pi over 2, and then again 0 at 2 pi. But I don't care about 2 pi because this is a strict inequality up here. So it turns out at pi, both sine and tangent again are equal to 0, and so that gets us our 4th answer there. Okay, so hopefully that explained some of the stuff and made you a little less confused. Again, this is not an easy section. These are not easy problems because I'm asking you to put all of the information that you learn together and use it all at once. Okay, you can't just copy exactly what you see. You have to think a little bit for yourself, which is I know a tough thing to do, especially in a math class, which you probably don't enjoy the most. Okay, but there it is. For section 8.3, I'm going to have you redo the homework and redo the quiz so that you can improve your scores. Okay? In addition, there'll be section 8.6 videos that come up shortly.